When two devices on the SPI bus are communicating, they follow a basic timing diagram as shown in this figure. So first, what I want you to pay attention to is the S clock or the SPI clock. So in idle, when the two devices or none of the devices are communicating with each other, that particular clock is at 0. And this is again why it's not an actual clock, because at idle it's 0. If the two devices are not communicating, they're exactly at 0. When the master want to communicate with a certain device or a certain slave, what it needs to do is just needs to assert a slave select. So let's assume for the sake of simplicity, we're just communicating with one of them. So at T0 in here, we see that the master goes and asserts the slave select. The signal is sent to the slave select, and a couple of things happens generally speaking when we're actually communicating on the bus protocol. So there's driving or what we call shifting a new bit to the data line, and there's sampling or latching a bit from the data line. So we have driving and sampling. Driving is putting something on the wire, and sampling it is actually reading it on the register. So generally speaking, the driving and the sampling of one single bit is happening within one single SPI clock. So let's see how this is happening in the steps. So at the slave select, it goes to 0. Basically, it gets asserted. This indicates to the slave that I'm ready to communicate, and what you need to do is you need to start. So what the slave does is it actually goes and at the same time, it puts its B7 here, which is bit number 7, on the MISO, which is the master in, slave out. So in its output, on the output of the slave in here, it just puts its own bit 7. Okay. After a certain period of time, between which is here indicated as T1, the slave does put its own B7. So this B7 is different because it's the one from the master, sorry. So the master basically drives its MOSI output, the master out, slave in, and puts its own B7 on it. So this B7 is from the slave, this B7 is actually from the master. The time between T0 and T1, basically the time between the slave select and this particular moment, is actually the moment when the clock actually starts. Is actually not specified, so it can take longer or shorter. But what you need to pay attention to is now the clock at this point here is actually when it starts. So this is when we start the clock, and at this particular moment, both the slave and the master have their bits ready at the output. So what happens is we wait for the next for the next active edge of the clock actually in here, which is T2. It's actually not an active edge because the master is controlling it. So what we do is we wait for a certain period of time. The master controller waits for a certain period of time, and let's say it waited and now it reached it at T2. The first thing it does is actually goes and raises the S clock or the SPI clock. So it raises it, indicating that this is basically a positive edge for this particular clock. And in this particular mode here, we have the both of the masters and the slave will actually go and sample that B7 and sample that B7. So the B7 that was on the MISO now is exactly inside the master, and this one here will be inside the slave because it's basically got shifted into it. And then we wait for a certain period of time based on the clock, and what happens is the master drives the clock to 0. Remember, it's not an external clock. The master driver is, or the master controller is the one that is actually doing the driving of this clock. So it actually puts it down, and at the negative edge in here, what happens is the next bit is driven at the slave, and the next bit here is driven at the master. Again, we wait a little bit, and then here and the next active edge of the clock, what we have is both of them sampled. And you repeat this for B5, B4, B3, B2, B1, till you reach T5, and at T5 you sample the last bit, or the least significant bit here. We're sending the most significant bit first, and this is actually not defined by the standard. You can send the most significant or the least significant based on the peripheral you're actually communicating with, based on the slave you're communicating with. So after you're done with here, what you do is you wait for a certain period of time, and at this particular moment in here, at T6, the clock has ended, okay, and that's pretty much it. We are done. So between the clock ending and actually the last thing that the master does, which is actually telling the slave that I don't want to communicate with you anymore, so it actually deassert the slave select. This particular timing is also not defined in the standard, so you're going to have to look at the default values for your particular slave or particular peripheral you're communicating with. The most important thing that I want you to get out of this here is the following. So driving happens on the, or actually driving happens on the negative edge of the clock in here. This one here drives, this one here drives, this one here drives, this one drives. All of these here are actually driving a new bit to the line. However, sampling happens on the positive edge, on positive edge, and positive edge, and positive edge. So we're sampling exactly the positive edge. That's actually in this particular setup. The only exception is the very first one in here. So what happened is we have driven, at least from the master, we have driven it on not on an active, not on a negative edge, because this is where we started the clock. This is the only exception. This is not the only two ways, basically the positive edge or the negative edge. It can change, and changing whether you're doing the driving or the sampling on the positive or negative edge results in different operation modes. So let's see what these operation modes are.